So when we begin looking at this as a whole class, I asked these students to take a look at our example, where we've got the AS406 plus 6 carbons to liberate out the arsenic, create carbon monoxide. And the first thing we do is look and see where is the stress. So in this case, the carbon monoxide is on the right side. So students know that this can only affect the reverse reaction. And then we look at how did we stress it. We added CO. So now we know that the reverse reaction, when we add chemicals, that speeds up a reaction rate, so the reverse reaction has to be increased, and that's why this equilibrium will shift to the left. Likewise, when we then look at the AS4, it's also on the right side, so we're also affecting the reverse reaction. But because we're removing it, we have to be decreasing that reaction rate, which is why the reaction in turn will then shift to the right. So as we look at the next one together, the first thing we do is identify what type of reaction it is. So we look at the equation. Nitrogen plus oxygen plus heat gives us nitrogen monoxide. I ask the students where the heat is. They identify it properly as being on the left side. So we're putting heat into the reaction, so it's endothermic. So when we increase temperature, we're changing the heat. We're changing the left side. So since we're changing the left side, we know that we are dealing with a forward reaction. And we're increasing it, so we know we're making that forward reaction faster. So we're increasing the rate of the forward reaction, so this is going to cause a shift to the right because the forward reaction becomes dominant until they return to equilibrium. When we look at part B, adding NO, we identify where the NO is. It's on the right side, which means it's going to be dealing with the reverse reaction. And again, we're adding, so we'll be faster. So if we speed up the reverse reaction becomes dominant. That pushes us back to the left. So by identifying where the stress is, and then is the stress an increase or a decrease, this is going to allow students to identify which reaction rate is affected and how it's affected, and then identify the shifts.